Testing. Okay, page 89 in our um, handbook. We're going to be learning about obviously furthering our paragraph development and making sure our paragraphs sound. We're working on clarity right now, and one of those things is talking about misplaced modifiers. Okay, and what misplaced modifiers are basically, they are places where maybe phrases or clauses should not be. All right, so if you're describing maybe one thing in the sentence, you don't want it to be after whatever it's describing, or it's just like a mix of a lot of things. Sorry, guys, in the back row, I can't really see you, but make sure you guys are paying attention, okay? I'll just move over here. That'll be a little bit better. But look at 18.1. Okay, 18.1. Place the modifiers near the words that they modify. Pretty self-explanatory. A word that should be modifying something else is that needs to be by that word. They modify. Um, Look at your examples. Only he liked Sarah, okay? Or he only liked Sarah. The he liked only Sarah, okay? All of those are describing where you should be modifying them. Um, the word only is describing different words in the sentence, so it goes to show you that um, where you place your modifiers really matters, okay? Look at your next example. The missionary from Kansas showed some pictures of heathen tribes. Okay, so from Kansas is our modifier or our phrase telling us where he's from. Okay, so it's saying where he's from Kansas. Look at the next sentence. The missionary showed from some pictures from Kansas of heathen tribes. So, was he in Kansas when he showed those pictures? Okay. The missionary showed some pictures of heathen tribes from Kansas. Are the tribes from Kansas? So make sure that these modifiers are appropriately placed within the sentence. Okay. Look at 18.2. Adjective phrases and clauses, in most instances, should come immediately after the words that they modify. So a lot of times the adjective words are going to be right next to the word that they modify. Okay? Look at your example. The car was stopped alongside the road with one headlight. Okay? With one headlight should be describing car, but notice that it's after the word road. So is it saying that the road has one headlight? It's not the whole point of the modifier, okay? You want it to say the car with one headlight was stopped alongside the road. Same thing, the house is still owned by our family that grandfather built. Okay, is it talking about the family that grandfather built? We want to have the house that grandfather built. So the house that grandfather built is still owned by our family. Okay, 18.3. An adverb phrase or clause that modifies a verb may be placed before or after the verb it modifies. Okay? So with adjective phrases and clauses, they come after. With adverb, it could be either or, before or after. Okay? Look at your example. Before the verb, when you leave, please close the door. Okay? It's before the verb close. Please close the door when you leave. It's also the same as if it were before. Okay, so adverbs, they can be placed before or after. 18.4, an adverb phrase or clause that modifies an adjective or an adverb is usually placed after the word it modifies. Okay, so look at this. The first one, we're talking about a verb. If an adverb phrase is modifying a verb, okay, if I think you guys are on your phones, please put them away. Okay, thank you. An adverb phrase or clause that modifies an adjective usually placed after. Okay, so verbs, they can go either before when it's an adverb clause, when it's an adjective or an adverb, it goes after. For example, Nicole was anxious about her new job. Okay, it modifies the word anxious. You want it to be after. Okay, you can't say Nicole was about her job anxious. That doesn't make any sense. Okay, so it goes after. Same thing. My sister can sing better than I can. All right, so this phrase, then I can, clause, goes after the adverb better, all right? You wouldn't say my sister can sing than I can better, all right? So everything, if it modifies an adjective or an adverb, it goes after. But with a verb, it can go before or after. Okay, 18.5. Place adverb modifiers as close as possible to the words that they modify. Again, self-explanatory. You want words to be close to the words that they modify. Look at 18.6. Avoid squinting modifiers. Okay, a squinting modifier is one that is placed between two words that it might modify, causing confusion. Basically, you don't know what it's talking about, so kind of avoid that. Look at your example. The coach said in Houston we would have a doubleheader. Okay, so we don't know if he's saying this in Houston or if he's talking about that we're going to have a doubleheader in Houston. Okay, so you want to be clear on, like, specific on where you're placing the word in Houston. For example, in Houston, the coach said we would have a doubleheader. Okay, so that's talking about that they were in Houston when he said it. And then the coach said we would have a doubleheader in Houston. That's talking about where the doubleheader is, talking about when they would have it or where they would have it. Okay, so be clear with your details. All right, we're going to get to 18.7 tomorrow because that's exercise 72, but let's work on exercise 71 in our workbook. Exercise 71, page number 35. Okay, if we get this done today, we won't have it for homework, so let's go ahead and get it done. Exercise 71, page number 35 in the workbook. Okay, so talking about misplaced modifiers, you need to underline each misplaced modifier and then put a caret at the place where the modifier should be. Okay, or you can draw an arrow to where you want it to be. Okay, if the sentence is correct, put correct to the left of the number. All right, look at number 1. The principal announced on Friday we would have a holiday. Okay. In this sentence, are we talking about when the holiday is or when the principal announced? Okay, so this is up to you to decide where you want to have it. It could go either before or after things, okay? But you need to make it clear, all right? Kylie, can you give me number 1? It is not correct. We just said we want to make sure that it's clear, okay? So in this case, we're moving on Friday to some place. We want to make sure that it's talking about when he announced it or when we're going to have the holiday. So where would I move on Friday? Good, okay? So Kylie moved it after holiday, after holiday. So your sentence would be the principal announced we would have a holiday on Friday. Okay, that's more clear than when the on Friday in between the two clauses there, or the two sentences there. Okay, you can also put it before the word the, talking about when the principal announced it. On Friday, the principal announced we would have a holiday. Okay, so just make sure that is going to squinting modifiers. Make sure that you are clear with what you want to describe. Okay, number 2. Mrs. Tompkins found the sweater she started knitting several months earlier in her cedar chest. Okay, when we read this sentence, we kind of see that maybe Mrs. Tompkins is knitting in her chest. Like, is Mrs. Tompkins in there? So we need to move a detail around. What would I move, Ellie? Not quite. Okay, a misplaced modifier, basically any phrase. Okay, so a phrase in there would be in her cedar chest. The reason why we want to move that is because it's talking about Mrs. Thompson. She had started knitting in her cedar chest. So this sentence is kind of saying Mrs. Thompson is physically in her chest. Did she do that? No, what did she find in her cedar chest, guys? Her sweater. So we want to make sure that in her cedar chest is near the fact where she found her sweater. So what would I change there, Michelle? Okay, where would I put that? Where it would make sense. Okay, I would put it before the word the sweater. So my sentence would go like this: that Mrs. Tompkins found in her cedar chest the sweater she had started knitting several months earlier. Or you can say Mrs. Tompkins found the sweater in her cedar chest that she had started knitting several months earlier. Okay? We don't want Mrs. Tompkins in her cedar chest, so we need to make sure that all the modifiers are near what it's modifying. Okay? Look at number 3. Rachel handed a bowl to her party guests filled with potato chips and crackers, snack crackers. Okay? This sentence is saying that her party guests are filled with potato chips and snack crackers. But what was really filled with potato chips and crackers, class? The bowl. Okay, so we want to move that modifier to the bowl. Grace, what do we have there? Where? After bowl. Awesome. Okay. So Rachel handed a bowl filled with potato chips and snack crackers to her party dress guests. Good. Okay, number 4. I found a uniform my father wore during the war in our attic. Okay. This is saying, where's the war, class? In the attic. Do we have the war in the attic? No. So we need to we need to change in the attic to modify what? What? Where we found it. Okay, so we found the uniform in the attic, so where would I change that modifier, Victoria? After what? Okay, I found a uniform in our attic that my father wore during the war. Kind of, not quite. So then it would be saying, I found a uniform in our attic that my father wore, saying he wore the attic. So we would change it to be in front of the uniform. Okay? I found in our attic a uniform my father wore during the war. Or, in our attic, I found a uniform. Okay? So it goes before the word I found or after I found. Okay? It's all right, we're practicing these still. Look at number 5. The Gulf War veteran gave an account of how he was held as prisoner of war for 3 weeks during yesterday's assembly. Does that make any sense, class? No, it's talking about during yesterday's assembly for 3 weeks. So what is during 3 weeks talking about? Good, how long he was being held as a prisoner of war. So Ian, where would I move during yesterday's assembly? Okay, good. After account, the Gulf War veteran gave an account during yesterday's assembly of how he was held as a prisoner of war for 3 weeks. Good. Or you can put it before the Gulf War veteran at the very beginning. Okay? Good. Number 6, General Schwarzkopf could see the troops peering through his binoculars. Okay? General Schwarzkopf could see the troops peering through his binoculars. So all the troops were looking through his binoculars, class? All at once. Okay, what would we change here, Noah? What would we change? What's out of place here? Peering through his binoculars. Who was peering through his binoculars? Good, so where would I move it? Good, you can say General Schwarzkopf, peering through his binoculars, could see the troops, but you could also move it before General Schwarzkopf. You can say, peering through his binoculars, General Schwarzkopf could see the troops. Okay? Number 7, he had only finished 3 pages of his homework by the end of study hall. Ricardo, what would I change here? He had only finished. What was it? Yes, that would make sense, but here, by the end of study hall, could be there, and it would be correct. Okay? So it's kind of giving us an example of our modifier of an adverb. Okay? So only is my adverb. In this sentence, it's saying he had only finished 3 pages. Okay? But we want to say how many pages he filled, or he had finished. So, what do I need to move next to 3 pages? Anybody want to help him out? Michelle? Good. You would underline only and then move it before 3 pages. Ricardo, here's why. So, in this sentence, when only is in front of finished, it's emphasizing that he only finished something. He was supposed to do something else with it. Okay? But we want to make sure that when he finished it, we want to know that he finished only 3. So that's why we need to make sure that we're talking about, or we're putting our modifiers in the correct spots. Okay? And then number 8, in this photograph, the man shaking hands with the president is the Secretary of State. Is there anything that needs to be changed in our class? No, number 8 is correct. Okay? All right, we'll practice those more tomorrow, but there's no grammar homework for tonight. Exercise 71 was our homework. So for those of you distant learning, if you were following along with us, awesome. Tonight, for literature, you are to study your poetic devices for tomorrow's quiz over accent to antagonist on page number 490, okay? Page number 490 is what you need to study, the word accent all the way down to antagonist. There will be a quiz on that tomorrow. And then tonight for vocab homework, write your roots, your prefixes, and your suffixes twice. But let's go ahead and turn there, and then we will be done. Okay? Turn in your vocab books to your roots page on page number 59. Page number 59 in your vocab book. Okay, I'm going to say the roots, the prefix, or the suffix. Please say the definition, okay? What does a or an mean? Not without. N or m. Into causative. Post. After. Sub. Under. Okay, moving on to roots. Art. Pretty easy. Art is art, skill, or craft. Cern or cret. To separate, to distinguish. Make sure everyone's participating, okay? Chord. Fort. Strong. Mit or miss. To send, to let go. Fawn. Sound or voice. Rap or wrapped. To snatch, to seize. Or secu or secut. To follow, okay? And then last but not least, the suffixes. What is ant? One, who, that, which. What is ori, one? Like, pertaining to. Ori, to, or orium. Okay, place, where. Thing, which. And then ous or ose. Having the quality of. Okay, let's go ahead and do number 2, all right? Everyone fill in the roots meaning for the word wrapped, which is what, class? To snatch, to seize. What is OR? Okay, some of us are going to have to look up. These ones are what we already should have learned, but suffixes are on the very back page. What is OR? Okay. or is one who, that which, or state, quality, and act of. Okay, another suffix on the very last page is ial or al. What would that be, class? Al. Good. Okay, like pertaining to. Everyone should be turning on the very back page with us. I know. Like pertaining to. Okay? You can raise your hand and tell me the literal meaning of raptorial. To snatch, to seize, one who, that which, like pertaining to. So what would we do with that one? Kylie, you want to give it a guess? Good. Pertaining to one who seizes, or pertaining to that which seizes. Either or. Okay? Number 2, atheistic. What does a mean? Not without. Okay. The or the, what would that root word be? Okay. What would it be? God. On the very last page, the, or theo, means God. What is ist? One who. Okay. One who. And then everyone look on the very last page, the suffix of ick or ickle. This case, ick. Like pertaining to. Good. So what's my literal meaning, Ian? What was it? Good. Pertaining to one who is without God. Okay? Pertaining to one who is without God or without God. All right, and the last word. Discernment. Okay, discernment. Look at the prefix. What does the word dis mean? Apart, away, not. Cern, we see that on our page. What is that? Good. To separate, to distinguish. And then meant. What is the suffix of meant, class? Okay, on the last page it says that which, state, quality, act of. Okay, so dis, apart, away, not. Cern, to separate, to distinguish. Meant, that which, state, quality, act of. So what would the literal meaning be, Emma? Okay, well then let's try and figure it out. Okay, we have our dis, which is away, apart, or not. Cern, to separate, to distinguish. And then meant. It's a state, quality, or act of, or that which. Do you think discernment is that which? Okay, who has this one? Okay, good. The act of distinguishing apart. Okay. The act of distinguishing apart. Good. All right, so tonight write your roots, your prefixes, and your suffixes twice. Other than that, we already finished grammar, and then make sure you guys are studying for your quiz tomorrow in literature. Okay, are there any questions? All right, you guys are dismissed.
All right, welcome to Algebra 2. Let's go ahead and get started today. We are on 5.3, three variable linear systems. If you thought systems of equations were already kind of rough, you're in for a bad time. Anyway, systems of equations model data from areas such as meteorology, business, science, engineering, and education, although most applications require far more than two variables and more advanced methods. The method developed here for three variable systems is expandable to larger systems. The next chapter will discuss a method that, combined with technology, can solve systems of as many variables as needed. Simple computer programs can be written to automate the methods used here and to solve systems with hundreds of variables. So obviously we're not going to do that. But the solution to each two-variable system in sections 5.1 and 5.2 was the intersection of two lines giving x, y. However, the solution to a three-variable system is an ordered triplet, x, y, z. And a single equation in two variables is a line and a plane. A single equation in three variables is a plane in three-dimensional space. This three-dimensional space is often called Euclidean three-space, if you want to sound extremely pompous. The solutions to an equation in three variables form a plane in three space. Two planes can interact in Euclidean three space in three ways. Intersecting planes form a straight line at their intersection and thus have an infinite number of solutions. Parallel planes do not intersect at all, and any system containing two parallel planes cannot have a solution. If the planes are coincident, their two equations are multiples of each other, and they have an infinite number of solutions. And you see that there on table B on page 236 of your textbook. Notice that two intersecting planes cannot form a single solution. Just as two intersecting lines on a two-dimensional plane have one solution, three intersecting planes are needed in three-dimensional space to have one solution at a single point. The three planes may interact different ways, but they have a single solution only when they intersect at one point. The following table, table C on page 237, it shows the various ways that three planes can interact to help visualize what a system of equations look like graphically. So you can have one point with one solution. You could have one line with an infinite number of solutions. You could have two parallel lines with no solution because only two planes intersect at a time. You could have three parallel lines, in which case there's still no solution because only two planes intersect at the same time. You could have no solutions because the planes are all parallel, or you could have an infinite number of solutions because they're all the same plane. Now, in practice, we tend not to use graphical solving or even interpreting of a system, largely just because after two variables, it really gets complex quick. And so we just tend not to worry about it. We tend to just look at the numbers because that's usually what we're interested in anyway. The two following examples solve a three-variable system using the elimination method, but with two rounds of elimination instead of one. In the first round, choose two different pairs of equations, one equation will be used twice, and eliminate the same variable using each pair. This creates a two-variable system that can be solved using elimination. Once the value of a single variable is known, that value can be substituted into one of the two variable equations to find the value of a second variable. Finally, substituting both the derived values into one of the original three variable equations produces the value of the final variable. The solution is written as an ordered triplet. So I'm going to go through that and demonstrate that here with over two examples of how we could do this using elimination. You could also do this with substitution, but that's longer, and I'm not getting into that, unless the book makes me later. But then what we're going to look at toward the end of the section and in the next section is really some of the more, or we're going to start building it in the section, and then we'll talk about it more after the break. Is the method of elementary row operations. So we'll talk about that a little bit later, but that scales better than this does. So we'll teach you guys that here, but let me show you guys a couple quick ways to do, or quick is a stretch, a couple ways to solve this equation. So looking at example A, okay, I have example 5.3a. Notice I am writing small. Okay, this is going to be a long one. All right, so I have a system of equations where we have x minus, where's my cursor go? Minus 3y plus 2z is equal to 5. And then I have 2x minus 4y plus 3z is equal to 8. And then I have negative 2x plus 4y minus 2z is equal to negative 12. Now, very quickly, Going to point this out here, once we get into 3 equation systems, we start to label our equations with equation numbers. So we will call this one equation 1, this one will be called equation 2, and this one will be called equation 3. As long as you're consistent with your numbering, it's fine. It's just we want to know where an equation suddenly came from, and since we can't always color code, this is the simplest way of doing it. So I'm going to take equations 1 and 2 and eliminate x, and then I'll do that for equations 2 and 3 in just a moment. No, 1 and 3. Just kidding. Okay. Now, in order for equation 1 and 2 to eliminate x, I need to multiply equation 1 by -2. So I'm going to go ahead and do that. Okay, so I'm going to switch to blue for this part. So I'm going to have -2x plus 6y minus 4z is equal to -10. Yes, and this is -2 times equation 1. Okay, this is part of the reason for that notation, so we know what numbers came from where. Then I'm just going to use equation 2 as written as soon as I find my cursor again. Okay, and we'll just have 2x minus 4y plus 3z is equal to 8. And we'll go through and do elimination on these, and we'll call its result equation 4, just because that's next after 3. That's the only reason for that there. So -2x plus 2x is 0. 6y minus 4y is 2y. -4z plus 3z is -z. And this is going to equal -2 because -10 plus 8 is -2. All right, I'm going to apologize now. I'm going to have to go back to the light mode because I cannot see my cursor on this dark background. So I'm just giving you guys a heads up. There we go. Before the light suddenly changes. All right, so that there is my equation, or new equation. Then I'm going to go through and look at, I'm going to use equations 1 and 3 to also eliminate x. Yeah, we're just going to leave it. All right. So we're going to take, and equation 3 already has a negative in front of the 2, so I'm just going to multiply by +2 in this case. So we're going to have 2x minus 6y plus 4z is equal to 10. This will be 2 times equation 1. And then we're going to take equation 3 with -2x plus 4y minus 2z is equal to -12. And this is equation 3. We're going to perform elimination on this to get rid of the x variable, and we will call this equation 5. Yeah, sorry about the sudden light mode, but I really don't have a choice. I can't read what I'm doing. All right, so 2x minus 2x is 0x. -6y plus 4y is -2y. 4z minus 2z is 2z. And 10 minus 12 is -2. Now then, what I can do is I can take and, let's see here. You know what? The easiest way to do this is I'm just going to hide myself for a minute. So you should still be able to see me, okay? Or hear me, I mean. You shouldn't be able to see me anymore, but I'm just going to have to keep working up in the corner. So I'm going to take equation 4, which we took from the blue one, okay? So 2y minus z is equal to -2. This was equation 4. And combine that with -2y plus 2z is equal to -2, which was equation 5. And I'm going to combine those to make equation, well, it would be equation 6, but it's going to work out very nicely, so we're not going to worry about that. Okay, 2y minus 2y is 0. -z plus 2z is z. And -2 plus -2 is -4. So now I have a value for z. So z equals -4. And now I need to plug in to a different equation. I'm going to plug in that -4 to equation 4. So I'm going to take and do that 2y minus z is equal to -2. We're going to plug in that -4 here. Notice that I'm just solving backwards then. So then 2y plus 4 equals -2. 2y equals -6. Y equals -3. So now I've gone through and done that, okay? And again, this one here was equation 4 plugging in. And now I need to solve for x. Well, equation 1 already has x by itself, so let's go ahead and use that. All right, so I'm going to have x minus 3 times y plus 2 times z, and this equals 5. And again, this was equation 1. Okay, plugging in y, we know that that was negative 3. Plugging in z, we know that was negative 4. And solving the remainder of the way, we get x plus 6 minus 8 equals 5. So x minus 2 equals 5. So then x must equal... Nope, I did something wrong. Oh, rip. Negative 3 times negative 3 is positive 9, not positive 6. I just read it as addition. So we get 9 minus 8. And then I did it right the second time. That's weird. All right, so x plus 1 equals 5. Subtract 1 from both sides. X equals 4. And so then my answer is the ordered triplet, okay, where we get, kind of separated it out here. So we plug in x, which is 4, negative 3 for y, and negative 4 for z. All right, and that's the idea of what we're doing. Now, you done? Yeah. Cool. Now with that, we're going to go ahead and move on to example B. I'm going to do probably a little less color coding just because it's a bit inconvenient to have to keep changing colors. But I'm going to still try to keep it somewhat, I don't know, maybe I'll just keep it the same. It's not that much. We'll see. But hopefully that made sense as far as what we're doing. The biggest trick is to try not to make mistakes along the way, because if you make one, you can see how easily that would compound itself and make you go way off. Okay, so let's look at example B now. We have the system, negative 4x plus 5y minus 5z is equal to negative 6. This will be equation 1. We have 3x plus 2y plus 2z is equal to 16 as equation 2. And then we have negative 4x plus 3y plus z is equal to negative 10. Now, the only equation with one variable, with a 1 in front of the variable, is equation 3, and that's specifically z. So we'll eliminate z first. That's kind of how we make our choice, is whichever one is going to involve the least amount of fractions. Okay, so I'm going to start out with equation 1, so that will just get copied as is. So I'm going to have negative 4x, I suppose I can come back on screen. Negative 4x plus 5y minus 5z is equal to negative 6. Again, this was equation 1, and that can just stay as it is because I'm just going to eliminate z. So I can multiply equation 3 by 5. And so we get negative 20x plus 15y plus 5z equals negative 50. Okay? Then when we combine them, we will create equation 4. So we get negative 24x plus 20y is equal to negative 56. All right, so that's 1. Now let's do equation 2 and equation 3. So that way we can make z disappear from there. So we can go through and do we'll leave equation 2 alone, so 3x plus 2y plus 2z. Oh, no, sorry, I should probably use print. 2z equals 16. This is equation 2. And then in order to get the z's to go away, I'm going to multiply equation 3 by negative 2. To get all that to work. So I get positive 8x, negative 6y, negative 2z is equal to 20. Yes. Okay, I'm just double checking as I go. All right, so now we're going to combine these two, and that will give us equation 5. Okay, 8x plus 3x is 11x, negative 6y plus 2y is negative 4y. The z's go away, and we get 36. Okay, so now I have equations 4 and 5. That can be solved for, or used to eliminate another set of variables. I'm going to personally lean toward eliminating y because 20 is a multiple of 4, so I only have to multiply one fraction, or multiply one equation, excuse me. So, because of that, now I have to hop off screen again. Okay, so now we're going to pull equation 1, which is negative 24x plus 20y equals negative 56. Again, this was equation 4. And then I'm going to take and use 5 times equation 5. Okay, I can't draw straight lines. You guys know this. Okay, 5 times 11 is 55. So we get 55x. We get negative 20y, which works out nicely for us. And we get, oh goodness, 5 times 36, which is 180, according to the book. All right, then solving down, okay, 55 minus 24x is 31x. The y's go away, and we simply get 124. Divide both sides by 31, and we get that x is equal to 4. Okay, so that x equals 4 then is going to be used for solving in the next one. So let's go ahead and plug that into equation 2. Oh, the book does equation 1. You know what? I'm going to just use equation 1 only for the sake of, I don't want to rethink it. So we're going to use equation 1. So negative 24 times 4. You can do it with equation 2, but I don't want to differ from the book because then if I want to be able to see clearly if I mess up something real fast. All right, so negative 24 times 4 plus 20 times y, which is unknown, equals negative 56. Well, 24 times 4 is 96, so you get negative 96 plus 20y equals negative 56. If you add 96 to both sides, you get that 20y is equal to 40, which makes the division real easy. Y equals 2. Now that I have all of those pieces, let's plug into the final equation. Okay, and I'm going to use equation 3. This was equation 4, by the way. I forgot to label it. Okay. Now I'm plugging into equation 3. I get negative 4 times x plus 3 times y plus z, which is what I'm looking for, equals negative 10. Again, this was equation 3 I'm plugging back into here. All right, plugging in x, that's 4. Plugging in y, that's 2. And so I get simply that negative 16 plus 6 plus z equals negative 10. Negative 16 plus 6 is negative 10. Negative 10, or adding 10 to both sides, yields z equals 10. And so that leaves me with an ordered triplet. So x is 4, y is 2, and z, I wrote z as 10. Oh my goodness. No, negative, no, it leaves me with 0. Why did I? If you add 10 to both sides, you get 0. I don't know why. Okay, anyway. So we get 4, 2, 0 as far as our answer. Even if it's a 0, you still need the third variable. Okay, just to be clear, because we are in 3D space. Just like if you have an intercept, you still need a 0 in your ordered pair. You need a 0 in your ordered triplet if it doesn't apply. So that's the that's kind of the cop-out way of doing this. That's the way to do it if you really can't do it any other way. However, as you may have gotten, this gets tedious quick. Okay, and you have to be really careful, otherwise you can make a boneheaded mistake somewhere along the way, especially when you're using a whole slide like this one. So, what we're going to talk about now is elementary row operations. Now, the two examples I just did are representative of your first section of practice 5.3, just so you guys know how this stuff relates. So, practice 5.3, numbers 1 through 6, that's what you're doing there. But the other thing we're going to teach you is we're going to start kind of pre-teaching the next section as we look into this. And we call these elementary row operations. And there are 3 elementary row operations that you need to be familiar with. The first one is I can change to equations. Okay, so ERO1 is that I can swap equations. So I can take equation 1 and swap it with equation 2. We're talking about its position. Okay? So I can change equation 1 and equation 2, which is just literally taking them and flipping them around, because sometimes that's more convenient to work with. All right, elementary row operation 2, I can multiply one equation by a non-zero constant. For example, I could do 4 times equation 1. You may have noticed I was already using this notation. Okay, so that's the second elementary row operation. Elementary row operation 3 is we can add a multiple of one equation to another equation, replacing the second equation. So if I take 2 times equation 1, I can add that result to equation 2, and then I would replace equation 2 with it. Typically, we will not show this last part just because it's redundant. We understand it's going to go into the second one we write no matter what, but that's what we're doing. We are going to go into equation 2. So if all that just sounded like, why would we do this? Okay, trust me, it's going to make sense more later. Right now, you need to learn the operations. So let's look at example C. In example C, we are given the system of negative 4x plus 5y minus 5z equals negative 6. This is equation 1. And then we're going to have 3x plus 2y plus 2z is equal to 16. And then we're going to have negative 4x plus 3y plus z equal to negative 10. These are equations 2 and 3 respectively. And then off to the side, we're indicated that we're taking equation 1 and swapping it with equation 2. Okay? All we're doing is we're switching places. Oh, rats. Well, I'm guessing disappearing for a minute. All right, so with this in mind, first step in your answer is to give yourself a system setup and look for anything that's not changing. In this case, equation 3 is not changing. It's not happening at all. So I can just copy down equation 3. There's nothing changing. And then I'm going to relabel these as equation 1 and 2. Now that may sound weird seeing as we're switching places, but the labels stay in the same place in the system. Okay? So if I'm switching equation 1 and equation 2, that means I'm renaming them equation 1 and equation 2. If that sounds weird, it's because it is. Okay. I didn't write the book. It's not my fault. All right, so in that case, in equation 1 slot, I'm going to write equation 2. And in equations 2 slot, I'm going to write equation 1. Okay? And so that makes it pretty straightforward as far as what we're doing. And so that's the end result there. That's the goal. Now, right now, we're only learning the different types of operations we can do. What? No, you can swap any 2 equations. I think that's the question in chat. If not, follow up with more information. But with this, right now we're just learning how to do them, so that way in the next section we can learn how to put it all together. Okay? So this type of problem is not where we're solving it, we're just rewriting the system essentially. Okay? And so this is representative of what you'll do in the second half of the practice. Let's look at example D. In example D, oops, I am told we want to take 1/4 of equation 3 and put it into equation 3 slot. Okay? And so I'm going to do that. I have 5x plus 3y plus 2z is equal to 20. I have 2x plus 9y is equal to 36, and I have negative 24x plus 20y is equal to negative 56. All right. Christian, I see your question in chat about solving it. The pairs we grab as far as equations go at the very beginning, you're just picking whatever's going to make your life easy. So we used, going back to equation A, or example A. Sorry, I'm going to just hop back here and answer this question. No, it does not. That's my point. So we did equation 1 with equation 2 here. Let me get my laser pointer. Hold on. Where is it? We had equation 1 to equation 2 and equation 1 to equation 3 to make equations 4 and 5 in example A. But in example B, we did 1 and 3 and 2 and 3. The one you use twice is going to probably be whatever doesn't have a coefficient in front. That's really how you're going to pick. Like up here, we had an x without a coefficient in front, so we used equation 1 twice. That's the difference. You can use any pair of equations you want, but typically will involve, whichever one we have to use twice, will involve the one that doesn't have anything in front of the variable. That's how we pick how to pair them up. Hopefully that clarifies that bit. All right, if there's still more questions, go ahead and ask in chat and I'll deal with it at the end because I don't want to interrupt again. But let's go through and look at example D. Okay, so here I'm going to go through and I'm going to look at my system. All right, now here, I'm only working with equation 3. That's all I'm requested to work with. So I'm not touching equations 1 and 2, so those just get copied. Yes, there's a lot of writing in this. I'm sorry? And then for equation 3, notice we're multiplying both sides by 1/4, which is the same as dividing everything by 4. So I'm just going to go through and divide everything by 4 to get the new equation 3. Whoops, I don't know what happened there. The new equation 3. Okay? So negative 24 divided by 4, that's negative 6. Okay, so we get negative 6x. 20 divided by 4 is positive 5, or multiplied by 1/4 if that makes you feel better. And then negative 56 divided by 4 is negative 14. And so that whole system is now our answer. Because again, we're not solving the system, so your whole rewritten system is your answer for this kind of problem. Okay, for right now. We'll get more into the hows, whys, and whats later. All right, one more example, and then I'll let you guys go. But we do have time for one more, because this class does not get out until 2:05. We get example E. We're told to perform 5 times equation 2 plus equation 3. So we're taking one, and so this one's going to involve quite a bit more math. But keep in mind, this notation means that we're going to be replacing equation 3 at the end. Okay, so let's go through and write our given. We have 3x plus 2y minus z is equal to 9. That's a 2, promise. That's equation 1. We have 2x minus 4y plus 3z is equal to 12 as equation 2. And then we had 6x plus 20y minus 7z is equal to 45 as equation 3. Now, very quickly, and I'm going to write my answer bank here. Even though we're going to have to do some math that's going to need more space, I'm going to do that underneath. But my answer is going to be on top. And I can just copy down equations 1 and 2 because they're not changing. Okay? So this is equation 1. This is going to be equation 2. And then I'll leave a spot for equation 3, even though I don't know it yet. So equation 1, we can just copy 3x plus 2y minus z is equal to 9. Equation 2 is 2x minus 4y plus 3z is equal to 12. Now to get our new equation 3, I need to go separately and do an elimination step, if you will. So we're going to take 5 times equation 2, because that's what we're told to do. So 5 equation 2 plus equation 3. That's the goal of what we're trying to do here. Okay? So 5 times equation 2, we get 10x minus 20y plus 15z is equal to 60. Okay? And then equation 3 just gets copied. 6x plus 20y minus 7z is equal to 45. And so we go through and solve. 10x plus 6x is 16x. The y's go away. We get positive, is that 8? Yes, 8z. And then this equals 105. And that's what goes in. This result is what goes into that third slot. So we get 16x plus 8z is equal to 105. By the way, notice it is customary to skip space where a variable would go. That's why there's a gap between my x and z, because I'm leaving space for where the y term would be if it still existed. And so hopefully what at least this example does is kind of shows you where we're going to head with this, and that this is a much more organized method of dealing with a system of equations than just having scattered work everywhere. And so that's what we're going to try to get to here. But those are the 3 main elementary row operations that you will be doing. So on your exercises in practice 5.3 on page 242 and 243, again in that first section you're doing like examples A and B. In the second section, which continues on to the next page, you're doing much like what we did in examples C, D, and E. You're looking at the notation and you're taking the appropriate step. The equations are not pre-labeled for you. Understand that it will go 1, 2, 3 in order from top to bottom. Notice that there. So you guys tonight are doing practice. You guys are doing practice practice 5.3. You guys are just doing the green problems. You guys are doing the green problems only. And then tomorrow you will have a quiz over 5.3. So make sure you get it down. And that will be that. All right. I will see you guys later. Have a great day.